Okay, so in this video, we're going to go through the workflow process of getting soil data, both the actual numeric data as well as the spatial data, into Rhino and Grasshopper so we can do some nice comprehensive analysis of all that information. Uh, the process is a little chaotic at first. We're basically going to use GIS data, in this case QGIS, in our area of interest, which is basically our site area, and use that to reference our soil information, which can then be brought back into QGIS, join the spatial numeric data, then take that and export it to Rhino and Grasshopper. So it sounds a little crazy at first, but it's very helpful to understand this workflow. In this case, we don't have a lot of soil variation and different types. So it seems like maybe it's a lot of effort for not a huge kind of output. However, if you can imagine having a lot more variation in soil types, having a lot of layers of information, it does a good job of seamlessly uh, joining it all together so that way everything kind of matches. It creates a much better workflow in that case. So like I said, we start off with this rectangle, which is our area of interest. That's kind of a good terminology, especially with the web soil survey. That's how they kind of understand these areas. But that's basically used to frame out our actual site location. So this is a clipped aerial image. There's a site boundary, which is our parcel. This all came from a satellite image that was also used to clip a height field image, which gave us contours, and they all have elevations with them. So it's a good way to kind of just start off with some of this base geometry to reference and match everything. And I'll have another video that kind of goes through that process because that's also really important. But for now, we can just, if you have that, great. But this is where we're going to start off for. Like I said, I'll have another video at some point going through that process. But like I said, you use that to start to uh, match and reference everything in Rhino and Grasshopper. So here again, you see that same clipped aerial, the site boundaries. I'll go into my perspective to show why we want to go into Rhino. So now we've taken those contours and actually lifted them to all their respective heights. We've used those contours to create a mesh. That mesh can then be used to help create a surface of that same terrain. So depending on the type of analysis you want to do, sometimes it's good to have a surface, sometimes it's good to have a mesh. We can even start to actually reference the aerial onto the terrain or the terrain mesh or surface, which is also interesting. I think that was covered in a previous video, but this is again where we'll start to bring that into here. So let's jump back to QGIS. So from here we have our areas of interest rectangle. This should be a file that you save on your computer if you weren't already provided with it. It's just a matter of saying export and save feature as and choosing a location on your computer to do this. So it's going to package everything that's needed to use for other purposes. So the next thing you want to do is go and Google web soil survey. That'll give you this first link. From here, we click on this green button to start the web soil survey. You can see we start off with this map of the continental US. You can either kind of just manually zoom into the area that you are going to be doing your analysis for, or you can actually just start off by using this first tab to import your area of interest. So they just initial it AOI. So I'll click on these down arrows. Create area of interest from shapefile. So here it's asking for, again, the package of files. So first one is that shapefile. Like I said, I've already provided these or have them on my computer. So here's the shapefile for that area of interest. The next one is the SHX. which is this other one with the, so AutoCAD compiled shape. You'll see too when they get brought in the file extension at the end too. Projection and the DBF, which is optional, but it's always good to provide it if you have it. So now we'll do set area of interest, and like I said, it'll bring us right into that area that we want to do our analysis for. Let's zoom out a little bit, so see if it'll get too crazy or too far. It looks like I'll try to zoom back in. Okay, that's good enough. Can always zoom down, but here you go. So now we have our area of interest figured out. So this is, again, kind of make sure we have everything matching nicely. The next thing you can go to is now the Soil Data Explorer. So this is basically all the different categories of data that you can find. And it even starts off with kind of even just giving you a little introductory on all the information, includes suitabilities and limitation for use. What I'm really interested in is the soil properties and qualities. You can even look at ecological site assessments and soil reports. But like I said, we're going to utilize the properties and qualities to get a lot of this information from. So you can see that there's only a couple categories, but when you do the drop down, now there's all these other subcategories as well. So we can obviously look at those kind of chemical properties, look for pH levels, soil erosion factors, soil health properties. So you'll see that there's some kind of repetition with these. So surface texture is pretty common in a lot of these, but that's obviously a very helpful thing to have. So I'll first start off by looking at, the soil surface. So from here, you'll get this information. If you want to see a more detailed description, you can select that. Aggregation method, you can just start off with kind of a dominant condition. I usually don't mess with too much of this, so I'll just go ahead and say view rating. And here you'll see it creates a color key map of all your different soil textures, with also the information of what those are. So it gives you the actual more kind of detailed name versus how that's rated in terms of a soil texture. It even gives you a percentage of how many acres of your site is that, or the percentage of it. So you can start to see that the majority of it is of a gravelly fine sandy loam, very gravelly sandy loam, so it's more of that kind of type. Let's also look at let's look at our kind of erosion factor. So I'm just going to look at K-factor whole soil. Again, view detailed description, view rating. So every time you run one of these ratings, it's going to basically keep track of that. So when you export it, it'll bring in all of this. So you don't have to do a separate export for each rating system. Every time you run one of these, it's going to create a thematic report of these conditions. So here again, you can kind of see the ratings for the T factor for, or sorry, the K factor for erosion. We can also look at the T factor, so I'll just run this one as well. Again, these values might not mean a whole lot. However, when you start to actually run the erosion calculator, all these ratings help you actually assess it. So you can see just how much information you can start to pull from this. Once you have collected all the data you want, then you'll go back up to here and say download soils data. And you can get like entire large data sets beyond your area of interest, but obviously we just want to focus on our area. So we'll say create download link. This will take a second. And now we can see at the bottom, download link as a zipped file. So I'm gonna go ahead and place that here. Once that's done downloading, there shouldn't be a substantial file size. I'll go ahead and extract it. And again, it gives you a lot of information, but I'll show you how you can just kind of filter that down into the more important things. So we'll go ahead and click on here. So like I said, that gives you spatial data, tabular data, and thematic data. So the spatial data is what you're going to actually use as your GIS shapefiles. So you can see there's a couple different shapefiles in here. Again, we're only going to have to focus on the soil MUA underscore area of interest. It also gives you tabular data, which you actually don't need to really deal with at all. And then there's the thematic data. So these were every report or rating that we ran. Unfortunately, it doesn't actually give you the name of those reports, which is kind of annoying. So what we really care about are obviously those ratings. So it'll give you a comma separated file. So this one's kind of easy. This is obviously the soil texture one. This other one, again, if you're not familiar with these, you probably have no idea which ones those are, as well as this other one. So you might want to rename your Excel files once these have downloaded, and in order to find out which ones they are, just go ahead and close these, is if you look at the legend. So you can see that the numbers are going to match up. So this one that ends in 4.5, this one that ends in 4.5. So if I go to legend, oops, sorry, not the legend. If we go to the parameter, so parameter for that one, you can see that it says near the top soil health, surface texture. The 6.2 is K factor whole soil. 68 is T factor. So you could always do, just to help kind of help you remember, it doesn't really matter what you label these or that you label them. It'll just help you kind of remember which one's which. And then this is soil texture. Okay, so these are really the only files you need to worry about out of all of this. So these ones that say Microsoft Excel, comma, separated value files or CSV files. So we're done with our web soil survey. So now we can go back to QGIS or ArcGIS, whichever one you're using. And I'm going to now bring in that shapefile. So I can go to layer, add layer, and use add vector layer or Control Shift V. Look for that area of interest that I just downloaded. So again, we're going to go to our spatial, and we're only interested in our soil MUA underscore area of interest. So now we'll add that, close, and now you can see that we've got that same exact kind of delineated areas that we had from our soil survey map. Right, so same thing, this is just showing those lines. But you'll see if I click on the properties, I don't have any of that information that I was looking at, such as the soil texture, the K factor, the T factor. None of that's actually included, which is where you have to do some merging of this information. So the next thing you want to do is actually add a layer for your text data. So again, I'm going to go to layer, add layer, and now I'm going to use the add delimited text layer. So I'll search for that file. So again, these are all in your thematic folder. And now, like I said, I'm only interested in these files. So I'll start off with soil texture, add. So it is a file format, like I said, is CSV. We want to make sure that we have, it'll default to point coordinates, which this is, again, tabular or text data, which has no actual spatial information. So it'll by default have that selected and it won't let you add it, see? But if you say no geometry, attribute only table, that'll allow us to add it. And you'll see that, again, we've got our columns of information. Some are kind of just, they refer to it as dummies, just kind of a placeholder. But then we've got all our texture names. So we'll go ahead and add that. So now you'll see that we've got this new layer that if we look at those attributes, it's the same thing we saw. We could do a little bit of cleaning up on this. So I'll actually do that later once I merge this. But this is where we have to figure out how to actually kind of join it all together. We have to utilize something that's in this table that matches or corresponds with our spatial data. And in this case, what we need to use is this MU key column. You can see that this gives us a 6-digit number. We can see that it's also available in this table. In this case, it's over to the left, but this is how we're going to use both of these layers to join them. So basically what I want to do is join this numeric data with our spatial data. So I'm going to go ahead and double click on here on our spatial data. So our soil MUA area of interest. And I'm going to go to this area where it says joins. So I'm going to click on this plus sign. So join layer, what I want to join is our rating layer. What field? So again, this is where we have to make that correlation between the two. So map unit key from that layer with our target field, which is the MU key. So it's basically both representing the map unit key. One is just abbreviated, one is spelled out all the way. And then once you do that, you can just go ahead and hit OK, apply, hit OK. And now if I look at the properties for the spatial data, now I've got the soil textures added to this. It gives you, again, all the information that comes with it, so you can start to actually edit this and say, you know what, I really don't need all of this information, especially if it says null. So let's go ahead and, I don't know if, it might not let you delete that, but that's okay. The other things we could get rid of is the, do it this way, so we don't need this column. This is actually government land up here, so that's why I think it's actually military land, so that's why they aren't providing that information. So we can always just delete that. You'll see that it does kind of get rid of it, so it's up to you on whether you want to keep that or not. Let's actually just undo that because I don't know if that's going to affect the next process. So let's just again kind of go through that process one more time to add some of the other information. So I'm going to go to layer, add layer, add this text layer. Now I'm going to add the K factor. Again, comma separate, no geometry, perfect. Now I can, again, I'll show you here with our K factor. This is our rating systems. Again, they might not mean a lot until you actually apply it to the erosion erosion calculator. So I'll, again, go to here to join another one of those. In this case, we're doing K factor. Join field, same thing, map unit key with our MU key. OK, apply, OK. And now we'll see that we've got this new column. So let's go ahead and actually prepare this now for Rhino and Grasshopper. So from here, I'm going to go ahead and do export save feature as, do it as a shapefile. We want to use this project projection, so always kind of make sure that it's project CRS. I'm going to create this name file, and let's call this, I'm going to call this erosion data, or soil, let's call it soil data. That way we don't have this kind of joining all the base information. And we'll call this soil factors, I guess. I mean, you can label it whatever you want. We don't need to save this file to the map. And let's just go ahead and hit OK now. So now in Rhino and Grasshopper, we're going to use, again, another plugin to bring in GIS data. So I already used this one to bring in the contours that I had as well as the site boundary. So now we want to also bring in that latest file that we just saved. So for this, you're going to need to use the plugin Add It. You can get that from Food for Grasshopper. I believe I already have a video that goes over that plugin, but we're going to use the import and the data viz. So only two components from this. So first it's looking for that shapefile. So I'm going to go to parameters, primitive, file path, do set1 file path, go to my soil data one I just created. So this is our AutoCAD shapefile, soil factors. It needs to have a Boolean toggle to actually run it. So I'll do that to true. And I'll plug this S into that S. The next thing I want to do is start to filter out some of this information. So this F is giving us all our columns. So we have our different labels for those columns. So if we go back to here to QGIS, we can see which ones were which. Oops, let's close that one. So let's look at which ones we want. So rating 1-1. So unfortunately, it doesn't bring in all the information, which is kind of a little bit annoying, but we can assume probably this first one. So list item 4 is our names. And then the 4117362 looks like it's kind of abbreviated, so I think that's going to be list item 6 or whatever column that is. So this is the kind of part of it that's a little messy, but if we count just 1, 2, 3, 4, 5, or if we count technically by the list item, so 0, 1, 2, 3, 4, 5, 6, 7. So we want columns, list items 4 and 7 for now. So let's go ahead and do that. So I'm going to do sets, list item, and choose list, like I said, 4. Oops, let's do that and hit 7. Make sure that this is multi-line data. So now here's my indexes that I'm curious or wanting to use. Now I can drag that into this get value of the feature. And now I'm also going to run this. For some reason, that even though I've got that QGIS file in feet, it's still exporting them in meters. So I've actually had to run this additional script, which has a scale factor of 2.61 to get it to match everything else. So basically, I'm just going to copy and paste this part. So the geometry that I'm drawing, which are polygons, it's using the same this corner to match it. And now we can see that everything's matching up nicely over here. It's a little bit off, but as long as everything that brings in is matching, I think we're okay. So I mean, let's just double check. It is there, so it's just slightly off, which at this scale I don't think is a huge deal. All right, it still looks like it's matching the aerial pretty well, which is great. Like you can definitely tell that this soil type is like that, matching the kind of stream banks. And so in order to see those information, we can go to our values here, and here now we can see that the first list item is going to give us the texture name. The second one gives us our K factor. So if you want to actually start to show this information, you can show it through name or text information, or you can show it through another kind of representation. So if I just do the list item, which is defaulted to 0, that'll just give me the names of all these. If I want to do another one to give me the other factor, I'll do the list item as 1. So now we can start to, again, kind of create our inventory of information this way. So like I said, I can basically just label these by doing area to find the center point of all of these. Then I can go to display, text. I like to do 3D so I can control the size. So it's looking for the location to display that. That's going to be these center points. Text to display, that's these names. And let's see how small they are since it is at a scale. And then here we'll just do like 500. See if that gives us a decent size since it is all to scale, right? So there we go. And then it also gives us our color that we might want to use, or even the justification. So let's just do something like middle center. Okay. So now we've got our labels. You can turn off the center point. And then maybe we even want to, maybe similar to the web soil survey, we can use this to give us our color rating system. So let's try that now. So again, this is giving us numeric data. So I'm going to go ahead and actually flatten all this. So I'm going to flatten. Oops. It's also, well, once I flatten all of this, I could actually probably just flatten from here and flatten from here. That'll make sure everything matches, since we don't really have to worry about the branching too much. Actually, yes we do, sorry. Maybe I'll just flatten actually from here. Yep, so that's helping. So I can still see there's some that are just gravelly, some are very gravelly, some are extremely gravelly. Then I'll do the same thing, I'll flatten this one. And now I can actually look at I can create a color gradient. So I'm going to go to math to find my bounds, basically the highest value and the lowest value. It's reading red because I know there's that null in there, which is that government owned property over there. But it shouldn't actually affect anything. Now I can deconstruct these. create our color gradient. In this case, this is what my default is set to, so you can decide how you want to create that color factor. So I need to look at all of the values, as well as the start and the end. And again, don't worry in this case why it's red. It's just because there's that one value which is reading as null, but we're still getting all our other information there. And so now I can take these curves, make them a surface. In this case, again, there's different ways in which you could decide to represent this. Oops, maybe it doesn't want to. It does. Maybe it's, yeah, it's just hidden under this aerial. So let's turn off that one. Okay. And now I'm going to color each one of those based off of that display. Or this color gradient. See, there we go. So now we've got, so there you go. There's that government, which is white. Here's these ratings. If you want to see what those ratings are instead of the texture name, we could always, again, let's just copy and paste this one. So we're using, again, the same location. We're just using different text, which is this information. You can turn this one off so we can see that value. So there you go. So now you can see how we can bring that information. You can use a variety of different techniques to show that data now graphically. So that'll be it for this workflow. It's kind of good because it's one of those things, anytime you have to combine numeric data with spatial data, you can use the same process in QGIS for it. So.